Distinguished colleagues, good afternoon. It's December 14th, 2021, 2 p.m. Moscow time. And we're beginning the panel session for the defense of the thesis by Artem Strelnikov. The thesis is submitted for the academic degree of Candidate of Sciences in Chemistry. The specialization is Organic Chemistry 143. The topic of the thesis is Synthesis and Photophysical Study of Substituted porphyrin-fullerene dyads with face-to-edge Chromophores alignment. Under the order issued by the Academic Secretary of St. Petersburg State University as of September 16, 2021, number 8843/1, Alexandrovich, Doctor of Sciences in Chemistry, Professor of Organic Chemistry, Department of St. Petersburg State University, and the Director of the Institute of Chemical Processing of Wood Biomass and Technosphere Safety of the Kiri Forestry University, was appointed the Chairman of the Board. The order also approved the members of the Board, namely Dmitry Daryan, Doctor of Sciences in Chemistry, Professor of the Department of Chemistry of Natural Compounds, St. Petersburg State University, Ivan Zorin, Doctor of Sciences in Chemistry, Associate Professor, Head of the Department of Chemistry of High Molecular Compounds of St. Petersburg State University, Andrei Mirishenko, Doctor of Sciences in Chemistry, Associate Professor, Department of Laser Chemistry and Laser Material Science of St. Petersburg State University. And remotely we have Levon Petrovsky, Doctor of Sciences in Biology, Professor, Head of the Laboratory of Synthesis of and Nanotechnology of Drugs of the Institute of Experimental Medicine. Levan Borisovich, you hear us? Yes, I do. And also we had Eduard Zinkevich as a member of the board, Doctor of Sciences in Physics and Mathematics, Professor of Technical Physics, Department of Belarus National Technical University, and Professor of Hamnets Technical University of Germany, and accredited expert of the Russian corporation Rosnano, but he is absent. But still we have the quorum. And according to the provision, we should have more than 4 people. And we have 5 members of the board who are present. And our candidate for the degree is Artem Strelnikov. And Alexander Khlebnikov, Doctor of Sciences in Chemistry, Professor of the Department of Organic Chemistry of St. Petersburg State University, is the thesis supervisor. And I would like to inform you that the panel session of the Dissertation Board is being recorded and broadcast on the St. Petersburg State University website, and our session is also interpreted from English into Russian and from Russian into English. And currently we have an email address posted on the page with live broadcast of the board session, and all the listeners can submit their questions to Artem Strelnikov online, the questions regarding the thesis or the scientific discussion. And thus, they can participate in our discussion. These questions will be forwarded to me by our technical service, and I will read them out during the discussion. The questions must be related to the speech of the applicant and to the content of the thesis, and don't forget to give your name and position if you submit a question. Questions that have nothing to do to the scientific discussion and to the text of the thesis and anonymous questions will not be voiced. Under the order on the procedure of granting academic degrees at St. Petersburg State University, approved by local regulatory acts, the session of the Dissertation Board is valid, providing 2/3 of the appointed board members are present. And the total number should not be fewer than 4 people. Our Dissertation Board consists of 6 people. 5 are with us today, including 1 member of the board who is working remotely. We have a multimedia connection with him, therefore we have the quorum. And I would like to ask the representative of the Department of Dissertation Board Support to fill out the attendance list. Our session should not last more than 2 hours, and the agenda is as follows. First comes the chairman's presentation about the documents submitted by the candidate for the degree and their conformity with the requirements, followed by chairman's replies to questions, if any. Then the candidate's presentation providing an overview and findings of the research, 20 minutes for that. Then questions to the candidate regarding the presentation, 10 minutes per question. Then candidate's replies to the questions, 5 minutes for that. Then the reports on the thesis. The board members will be taking the floor in turns to provide their reviews and questions to the applicant, 10 minutes each. And chairman's report on the thesis, 10 minutes for that. the candidate's comments about the reports on the thesis and replies to the questions. 20 minutes will be given for that. Then open discussion. Speeches by those present at the defense with a brief presentation of their positions or questions or suggestions to the candidate on the topic of the research, no more than 2 minutes per person. And don't forget to state your full name, academic rank, position, and place of work in the registration list, and don't forget to introduce yourself when I give you the floor. Then I will ask the questions submitted during the broadcast via our website. I would like to draw attention to the fact that questions that will take more than 2 minutes to read out will not be voiced. Then the candidate's replies to the questions. Then the presentation of the candidate's thesis supervisor, 3 minutes will be given for that, and a 5-minute discussion before the open balloting on conferring or non-conferring the academic degree. The discussion of the results of the defense is not broadcast. Then we are going to have open balloting. We're going to count the votes and record the results in the protocol. Then we're going to make a decision on whether to confer the academic degree or not. And finally, we're going to listen to the finalizing remarks of the applicant. Any objections, dear colleagues? Questions? None? Okay. So I start, and first of all, I would like to ask you to switch off the sound on your mobile phones. So, the chairman's presentation. The thesis by Artem Strelnikov for the academic degree of Candidate of Sciences in Chemistry, the specialization 143 Organic Chemistry, is titled The Synthesis and Photophysical Study of the Substituted Porphyrin-fullerene Dyads with Phase 2H Chromophores Alignment. The thesis was approved for the defense by the order of the Academic Secretary of St. Petersburg State University as of August 25, 2021. Artem Strelnikov has prepared his thesis at St. Petersburg State University as a postgraduate student. And I've already introduced his supervisor. 3 published works describe the research findings, and all these papers are published in journals indexed in Web of Science and Scopus. All the documents submitted by the candidate for the degree are found in the certification file, and they comply with all the requirements. And the curator of the defense, the member of the Department of Dissertation Board Support, has all the copies. Before I give the floor to the applicant, I would like to ask you, members of the board, if you have any general questions to the candidate for the degrees. They need to consider the whole list of documents submitted by the candidate. No. No need for that? Okay. Artem, please, you have the floor, and you have 20 minutes for the report. Distinguished colleagues, my thesis is dedicated to the expansion of structural variety of porphyrin-fullerene dyads with an orientation of phase to edge, and to the study of some photophysical characteristics. Such dyads are a promising material for the use in photogalvanics and catalysis. The opportunity to use them in these spheres is explained by such the ability for charge separation and charge transfer. And in order to use these processes successfully, the lifespan of such charge-separated states should be rather large for the transfer of the charges from an initially excited molecule to the external chain. Previously in our lab, we obtained and studied the range of dyads with porphyrin substitution and orientation of chromophores according to edge to face orientation. And during excitation, they form long life states, and porphyrin substituents have an impact here. Another important aspect in the transformation of energy of solar light into electricity is the opportunity to transfer charge in the width of material. Baldam and Redeker showed, and porphyrin-fullerene ensembles of such content will be able to self-organize and form structures, and in these structures molecules are located like that with a turn. As a result, we have channels for the transfer of negative charge through fullerene part and positive charge through porphyrin parts. And this self-organization can be used for to produce photovoltaic substance units. And such a dyad was obtained and studied by our scientific group. Photogalvanic elements based on compound 1 demonstrated the presence of photoresponse, and it demonstrates that they can be used for photovoltaic units. And within the framework of this work, we considered the modification of dyad 1 that influences the characteristics of final compounds. And among the most important parameters that influence the characteristics of dyads, we consider the energy of electron coupling of donor and acceptor fragment, the distance between them, and also the character of intermolecular organization. We presume that mostly we see the impact of change of alkoxy carbonyl substitutes length in fullerene porphyrin part. And during the interaction of orbitals, we see the special impact, and this value can be influenced by the change of distance between the chromophores and by the change of substitutes in the porphyrin part of the molecule. Thus, the goal of this work was to find possibilities for modification of dyad structures and the study of some photophysical characteristics of the compounds. The goals are as follows: modification of fullerene fragment, also the changes of the character of substitution of porphyrin, A3b and AB2C, the change of linker length between chromophores, and the dependence of photophysical characteristics from substitutes. The first field of our work was modification of fullerene part of the dyad. We considered the cyclo-coupling of aziridines, A3, to fullerene C60. And the first step was paranitrophenol substituted compound, and thus we've chosen an approach based on stochastic substitution. And here you see what we worked upon. The restoration of retro group led to aminoporphyrin, and then we see the formation of imines, and then aziridine 3 is produced. And the final stage of synthesis is thermal coupling to fullerene C60. So that's a stereospecific process. We see different adducts that are produced due to this fullerene fragment. And we know that fullerene derivatives are poorly soluble, and the impact of substitutes in alkoxy-carbonyl substitutes influences solubility of aziridines and dyads. Thus, ethyl substitute compounds show poor solubility in chloroform and dichloromethane. That complicates the work process. And ambutyl substitutes make solubility better and allows to work with compounds in an ordinary regime. And hexyl dyads show wonderful solubility. And in order to assess the possibility to vary electron character of the core, we offered a range of compounds that have different aryl substitutes. Nitroporphyrin acquisition was secured by the methods that I've described before, but during the restoration we saw the formation of byproduct 11, and chlorine atom here is located in ortho position to the amino group. And the yield of the byproduct is increasing when we see the change of acceptor character of substitutes. Then fullerene coupling processes were conducted according to the described methods, and lower yields of porphyrins and ensembles is explained by complexity of cleaning of the purification process. And above all, we consider the opportunity of synthesis with AB2C, and that influences not just the electronic structure of porphyrin, but also leaves opportunities for further modification. And we've chosen an approach based on the interaction of two dipyryl components. One of them is transferred to the carbonyl derivative, and then it reacts with another dipyryl component. Then porphyrins are filtered through silica gel, and we were impressed by the simplicity of this procedure, and we studied the applicability of this method in order to obtain different substitutes. Further order of producing target dyads was tried, but we tried to restore nitroporphyrin, and as a result we got a very low target material compound. And when we use TFA instead of hydrochloric acid, we see what happens. Further reaction was conducted in standard conditions, and it allowed us to get 16th dyad with a good yield. And solubility of this dyad was rather high compared to the dyad with a similar substitution with 3D porphyrin substitution. In order to vary the distance between chromophores, we offer the set of compounds. The length of linkers was reduced continuously, and we restored the linear structure of the molecule. And here the linker compounds, type 3, correspond to dyad 16 that was previously produced. And the change of acquisition of compounds with different linkers require cross-coupling and the change of conditions. And a key intermediary here in this synthesis for linkers 1 and 2, that's acetylene aziridine 119, and its interaction with other compounds allows us to get the aziridine that we wanted. These conditions were achieved by selection of catalytic system and conditions of reaction in order to prevent the breakup of the ring. And the necessary compounds for bromine porphyrin, it can't be received by ordinary conditions. Therefore, we consider the opportunities for direct bromine. And as a result, we got brome-containing porphyrins in mesa and beta position. And we managed to resolve the problem using synthetic continuity, metallation, demethylation, and bromination. And mesabrom porphyrin reacts to the structural block 19, and then it gives us azirin 22. And cycle coupling reactions were conducted in ordinary conditions, and as a result we got a range of compounds with linker 1 and dyad with linker 2. The study of photophysical characteristics of the compounds were studied by the group of Tkachenko at Tampere, and using these compounds in different solvents, we studied the impact of porphyrin substitutes on photodynamic behavior of the dyads. And as a result, it turned out that, as we presumed, acceptor substitutes increase the energy of excited state. Using spectroscopy and absorption with femtosecond resolution, we managed to see that, depending on the nature of dyad and polarity of the environment, we can see that the transfer of electron with the formation of charge-separated states, the transfer of energy with the formation of fullerene state that is locally excited, or we can see both of these processes. And the table gives you the values of constants for elementary stages and for relaxation states. And in benzonetrol, all the compounds demonstrate the formation of charge-separated state. And when we shifted to toluene, the behavior becomes different. For acceptor substituted dyads, we see locally excited states and conversion. For 2A, we see the formation of axiplexes, and for 2G, we see full charge separation. And then the formation of this state leads to long-term lifespan, and that's an achievement by itself, because non-methylated porphyrins in different environments do not form such a state. Thus, in this work we offered the approaches to porphyrin-fullerene dyads, and it provides us the opportunity to create a library of such compounds. The distance between chromophores can lead to change of photodynamic behavior. The introduction of different types of substitutes into a porphyrin edge allows us to swiftly adjust the characteristics. And these modification methods could be a powerful instrument for varying the characteristics of compounds in a broader range. The conclusions are as follows. They are given on the slide. That's it. Thank you so much. Thank you, Artem. A very short report. You saved us a lot of time. Now, questions on the report. I would like to ask the members of the board if there are any questions. Yes, one. I have one. It's slide 14. Can you please show slide 14? No, the previous one, the 13th one. So it's interesting, this approach through bromination, can it be used for the introduction of aryl groups? Yes, theoretically, yes, it can be done. For the reactions can be secured, so that's a cross-coupling here, yes. And, well, I'm not quite familiar with such a chemistry. Can you obtain monosubstitute porphyrin, brominated, and introduce 3 others with a combination process? Yes, this can be done. That's a widespread approach to the formation of non-symmetrical substituted porphyrins. Thank you. Other questions? Artem, I have the following question about the photochemistry part. Can you please flick to the table? Yes. It's interesting for me to know why the shift in polarity and the shift in toluene increases. It activates the channel of triplet formation. Why does it happen? How can you explain it? It's likely that in non-polar solvent we have less charge-separated states, and therefore we see the transfer of energy from excited porphyrin without the formation of couple of cation radical and ion radical. And the only way of relaxation is this one. Thank you. And another question on the topic. You mentioned that there is axiplex formation and charge-separated state formation. And how do they differentiate? How did you differentiate it? Why do you say that in one case you have axiplex and in another case charge-separated states? For 2A, in spectral experiments, we observed the characteristics that are familiar not just for charge-separated, but we also had additional absorption mechanisms, and we decided that these are axiplexes. May I? Yes, yes, please. Please show us the 15th slide. No. Yeah. Okay. So here, the fullerene is drawn like the substitute is using the 5-6 connection, though it should use 6-6 connection. And this picture is a bit unclear. Could you please explain it? Well, I'm afraid that's the drawing peculiarity. Certainly it was 6-6 connection. Yes. So is it a mistake? Or what? Thank you. Now, if you look attentively, I'll try to show you. So this 5-member cycle. No, you have the 6-6 connection over here. So over here, you have 5-member cycle in the scheme of fullerene, and this connection can be only with for 2 6-member six-member parts. Okay, other questions? No, none. Ivan, are you going to ask anything? Yes, I wanted to ask. When you studied photophysics in solvents, didn't you trace some concentration effects? Because this was done at specific concentration. And I'm asking just for the future, you know, because I believe you plan to use these substances later on. And then you're going to require the work not with solvents, but with some condensed environment. And the question arises how photophysics will act depending on the concentration of the solvent, and this can be done and measured at this stage already. And maybe viscosity of the environment and this transfer from organic solvent to the possible condensed phase. So, yes, I got your question, thank you. Overall, in order to study the characteristics, we considered the solvents that were strongly dissolved in order to see the spectral characteristics, but we also conducted measurements in condensed phase during the production of photoactive elements. We obtained a layer that contained this dyad and evaporated the solvent and measured the permeability spectrum. And we observed similar characteristics. Thank you. And in condensed phase, you observed the charge separation or the energy transfer? Well, unfortunately, I can't remember right now. Okay. I'm not sure whether you have an answer to this question, but still, I wanted to ask it. Maybe you assessed photochemical stability of these substances. How long will they preserve their characteristics? Well, a typical experiment lasts for several hours. During this period of time, this diet is quite stable, and we conducted secondary measurement of irradiated samples within a certain period of time, and we observed no changes. So at least for hours they are stable, yes. And that's good. And it should be mentioned that we use powerful radiation for excitation, and the use of sunlight will have a softer impact and stability should be higher. Okay, yet another question. If you plan to use them, are they going to work in purely condensed phase? Or can you introduce them as a composite in order to obtain this stable film? So here you had them pure, yes, pure film of your substance. Did you consider the opportunity to use them with composite materials? Levon, you need to get back. Dear colleagues, I announce the first technical break. So we end the first technical break and we continue. Yes, thank you very much for the question. The study to of the opportunity to use polymer carriers is now considered by our group. And I know that recently we had photophysics studies for such compounds, but they're not dealing directly with my work. Okay, thank you. So, distinguished colleagues, any other questions? Okay, let me ask some. So, this slide 7, you had reduction. Where did you get chlorine? We use hydrochloric acid, and it can be the source. Though our attempts, so electrophilic forms, yes, our attempts to establish the nature of this reaction were not successful. So it can be radical. Maybe in the restored form you have this chlorine too, and there you can get this radical from. Yes, and as colleagues, I had a lot of questions on photophysical characteristics. So this slide 15, where you showed characteristics depending on the donor acceptor characteristics. So depending on donors and acceptors, you can have different characteristics. And for an unknown molecules, can you forecast what are the donors or acceptors that should be used in order to see some event? Some separate event. Well, simultaneously with the results of this work, we conducted quantum chemical studies that allowed us to develop a model that allows to forecast with high accuracy how energies of excited states interact, and we carried out quantum chemical calculation studies, and it turned out that quantum chemical model accurately predicts photodynamic characteristics than the actual photodynamic data. Okay, thank you. So you used molecules with different linkers. Did you study them? No. Unfortunately, we had just one linker that we studied, and then the pandemic started, yes, and we had to make a break. Okay, thank you. Any other questions? No questions, okay. Eduard Zinkevich submitted his report, and I'll read his question. Currently, a lot of porphyrin-fullerene dyads are synthesized, and regularities are studied of electron transfer, and porphyrin-fullerene dyads are new, and what are their characteristics on the stabilization of PZ states? Well, I believe to shortly answer, I should draw attention to the fact that I have one of the conclusions. We got such a porphyrin-fullerene dyad that at photoexcitation and non-polar toluene produces the charge-separated states that has a long lifespan. And that's a key peculiarity of these compounds. Okay, thank you. There are no other questions, and now we're going to shift to the reviews of the members of the board. You can answer each review at once. Yes, you'd better make it this way. Answer all the remarks at once for every review. So, dear colleagues, first I would like to give the floor to Dmitry Darin. Okay, thank you. Well, the thesis written by Artem is very relevant, and I had a very good impression on it. And the search for structures that can form long-living states with a charge of with a transfer charge, so it's quite relevant. And we see a very huge synthetic part that is dedicated to the development of approaches to the synthesis of substituted porphyrin-fullerene dyads, and also to the synthesis of dyads with different linkers. And the second part is dedicated to the study of photophysical characteristics of these compounds that It includes accurate analysis and interpretation of the results. And to my competencies, I'm going to comment on the first synthetic part. But I would like to emphasize here that this work is interdisciplinary and it's really quite applicable, and I believe these are the benefits of this work. The results of the study were published in 3 peer-reviewed journals, and they were also tested at 7 international and Russian conferences. Overall, the thesis is easy to read. It's written with good Russian and English language. It has practically no misprints and inaccuracies, therefore I won't dwell upon them. And I wanted to read out the relevant questions. First, in the literature review, when discussing the interaction of dyad structures with photophysical compounds, the author does not give us the structural formulas, and this complicates the understanding of material a bit. Then, for some compounds, 17A, 17B, 17C, you got values of molecular ions in HRMS spectrum, and they don't correspond with the calculations. And the conclusions are a bit contain a bit too many synthetic results. And then the question about the choice of method for porphyrin 7, schemes 34, 38. Why did you use this approach that gives you low yield, whereas in literature review on scheme 19 you see a bit more laborious but rather selective method? Then, according to your opinion, the increase of donor character of porphyrin fragments should expand the lifespan a bit. It's unclear why do you introduce porphyrin cycle for electron acceptor atoxy carbonyl group. That's diet 16. It seems to me that maybe you should have introduced more donor substitutes like dimethylamine group, or maybe use excessive rings. Then I wanted to ask whether you considered other types of linkers. I believe you lack biphonyl linker here. So why did you prefer to use ethanol fragment instead of the second phenyl one? And last question, according to you, methylation of porphyrin should lead to the increase of donor characteristics, and therefore did you consider the opportunity to study photophysical characteristics of methylated porphyrin-fullerene dyads? However, these remarks do not compromise the overall high value of this work. That is quite a successful academic study on the relevant topic. Therefore, I believe that the thesis of Artem Strelnikov, titled Synthesis and Photophysical Study of Substitute Porphyrin-fullerene Dyads with Phase 2H Chromophores alignment, meets the requirements of the orders of September 1st, 2016 on the procedure of granting academic degrees at St. Petersburg State University, and the applicant, Mr. Strelnikov, deserves the academic degree of Candidate of Sciences in Chemistry in Specialization Organic Chemistry 143. And Articles 9 and 11 of the above-mentioned order are not violated. Okay, Artem, please, you can answer. Yes, thank you very much for the review. As for the questions, I agree with a literature review comment. As for the choice of the method for porphyrin 7, stochastic condensation is single-stage method, and it was studied by our group. Therefore, we've chosen it as the key synthesis element, synthesis method. As for electron acceptor character of atoxy-carbonyl group, we believe that alkoxy-carbonyl meso substitutes are the result of the convenient method of synthesis of AB2C porphyrins, and as we wanted to study the characteristics of dyads, we needed to synthesize both donor and acceptor characteristics compounds. Did we consider other linkers? For example, biphonyl? Yes, we considered other linkers, but we implemented the ones that had common methodology. For example, we use 19th block. For metallation of porphyrins, yes, we planned these studies, but they were not covered by this work. And as for this remark regarding the conclusions, yes, I agree with that. Yes, I wanted to specify, do you plan to study more donor fragments in order to enhance the efficiency of the structure? So is this work ongoing? Unfortunately, right now, we are working on other fields. Okay, thank you. Okay, Ivan. Distinguished colleagues, I'd like to join in, and I would like to say that this work really is quite relevant, and essentially the vector of development of our civilization brings us to the enhancement of the role of solar energy and other pure types of energy. And no matter what we think about it, the science should pursue this path, and such works on the development of new materials for photovoltaic use are much needed. And it is correct that the author works in this field and is doing such studies because they are quite relevant currently. And essentially the work is, if you don't take relevance into account, it's pretty good by itself. And getting acquainted with it, I really enjoyed reading this thesis, and that's quite a rarity now, because this thesis is written quite accurately and shortly. So everything is described quite well. You read the literature, you understand why the author included some other positions. No excessive things. Everything is quite clear, and the coherence between the items of the work is clear. And in the experimental part, everything is also quite essential, and all this text is written in a way that you understand that these experiments were indeed conducted, and they were conducted quite accurately. They are reproducible, and I believe that's an important part, that this work on text is verified. It really gives you trust that all these experiments can be reproduced. So I had such an impression that you can take this work, and if you are a good experimenting scientist, you can reproduce them all and get the same results. Therefore, I believe that all the results that the author obtained are good, they are credible, they are reliable, and the publications in good journals confirm it somehow. So I believe that the work is written quite accurately, and we can fully trust the author and trust his results. And as for my comments and remarks, maybe I've already described it, but I'll read them out. I presume that an organic chemistry framework did not allow the author to demonstrate the next logical step in the study of these compounds. For example, create a photoactive material, film, and characterize the target compounds from the point of view of applicability of characteristics. But I hope that this work will continue, not within the framework of the thesis, but I hope that the author will demonstrate us that these substances will work in photovoltaic devices. And based on the detailed study of this thesis, I would like to conclude that the thesis by Artem Strelnikov, titled Synthesis and Photophysical Study of Substituted Porphyrin-fullerene Dyads with Face-to-Edge Chromophores Alignment, meets the requirements of the orders of September the 1st, 2016 on the procedure of granting academic degrees at St. Petersburg State University. And Mr. Strelnikov deserves the academic degree of Candidate of Sciences in Chemistry and Specialization 143, again in Chemistry, and Articles 9 and 11 of the above-mentioned order are not violated. That's it. Thank you, Ivan. Artem, please, you can answer. As for the practical use of dyads for photovoltaic devices, one of our articles described how we previously obtained films based on dyads, and they demonstrated the presence of photogalvanic effect. And at Tampere we launched the studies of photovoltaic elements. So here you see them here. But unfortunately, because of COVID-19 pandemic, we did not bring this study to the end. But still, these devices demonstrate the feedback, so we just need to finalize the studies. Okay, we hope that this will work well, indeed. Yes, Ivan, are you satisfied with the answer? Yes. Andrei Mereshenko. I also like the work of Artem. About the substances that can be used in order to develop photovoltaic batteries. And he synthesized a lot of compounds, 7 new dyads, 7 sets of compounds with different substitutes were tested, so that's a huge experimental load. And as for photochemical part, there were a lot of studies here as well, and what we've seen in the table on slide 15, it covers a lot. As an expert in spectroscopy, I know that in order to analyze the data of these mechanisms, you need to analyze and model a lot of experimental data. And there's the analysis of numerous spectra. There's a lot of work that was done by the author, and that's what the author describes in the theoretical part as well. And everything is adjusted to one model, and that's really great. And before the defense, we had preliminary expertise at our university, and during this preliminary expertise on photochemical part, I had a lot of questions. What I want to say is that Artem answered all the questions, and he took everything into account, and he corrected everything. And reading the thesis, I, painstakingly tried to find some weak points, especially in the photophysical part, because that's my field of study, and I did not manage to do that. So, no comments whatsoever, no negative comments. Therefore, I want to say that the work, this thesis is really of high quality, and I would like to see the continuation of these studies in adjacent fields as well, and I hope that Artem will publish more articles in more prestigious journals, because judging by the quality of the thesis, Artem is a very talented scientist, and I hope that he'll have a very good academic future. That's it. Therefore, I had no critical comments to this thesis, and I believe that the thesis by Artem Strelnikov, titled The Synthesis and Photophysical a study of substituted porphyrin-fullerene dyads with face-to-edge chromaphores alignment meets the requirements of the order on the procedure of granting academic degrees at St. Petersburg State University, and Mr. Strelnikov deserves the academic degree of Candidate of Sciences in Chemistry and Specialization 143 Organic Chemistry, and Articles 9 and 11 of the above-mentioned order are not violated. Thank you. Thank you, Andrei. As there are no comments, I would like to give the floor to Mr. Zinkevich, but as he's absent, I will read out his comments. So, Eduard Zinkevich notes that the thesis by Artem Strelnikov is dedicated to the search of convenient fields to the modification of porphyrin-fullerene ensembles that provides for the restoration of for the preservation of the forms and orientation, and also the topic is quite relevant, as Eduard mentions that the issues fully correspond to the current trends on the development of fundamental and applied studies and innovative developments in supramolecular chemistry. So he mentions the novelty of the results, and he says that the thesis describes the methods of new methods of production of such compounds, and above all, the review gives a positive assessment of the conclusions and assesses the economic value and social value of the results, and also mentions a few words about the qualification of the author, and the comments are as follows. I'll read them out. Part of the conclusions given in the end of the thesis mostly reflect what was done in the work, though essential in this part of thesis you should emphasize the essence of the results and their principal difference from the results that we've already seen in the literature. That's the first comment. Second comment, on page 55, in works 53-54 dedicated to the use of porphyrins as the transformers of solar energy, it's noted that the efficiency of charge separation can be improved by fine-tuning of potential of oxidation of porphyrin core. And the question is, this fine-tuning word is jargon, and here you should use well-known terms like energy of state, energy of local excited states, free Gibbs energy, and the value of activation barrier, and so on. Third question, page 55, the quotation from the thesis. We presume that the increase of donor character of substitutes in porphyrin should lead to the drop of energy of charge separated state due to delocalization of the positive charge, and this provision is baseless, is seen as baseless, because you need to give quantum chemical calculations to support it. And the last remark is also associated with a quotation, page 57, for preliminary assessment of kinetics of fluorescence etching. We saw the spectrum of dynamic emission using a single photon count as TC-SPC, and on scheme 61 you give typical picture of the drop of fluorescence on the studied compound using dyad 2G. And the question is as follows: from the point of view of expert in kinetic spectroscopy of organic compounds, this information should be described like that, as he offered. The damping fluorescence damping kinetics was studied using TC-SPC, and on figure 61 you see experimental kinetics of dampening of fluorescence of the studied compounds in solvents with different polarization. But overall, the thesis of Artem Strelnikov meets the requirements of the order on the procedure of granting academic degrees at St. Petersburg State University, and Mr. Strelnikov deserves the academic degree of Candidate of Sciences in Chemistry and Specialization 143, again in Chemistry. And Articles 9 and 11 of the above-mentioned order are not violated, so these are That's the review of Edward Sienkiewicz. So, Artem, please, you can answer. Thank you very much for reading them out. I agree with those comments that Professor Sienkiewicz mentioned. And as for the question on this baseless proposition, so this conclusion is made on based on the established notions about electronic effects of the substitutes. And I agree with the last remark. And as for the conclusions, yes, I agree with other remarks. With the three of them about the fine-tuning. Well, we believe that this term is quite simple and reflects the situation quite well, though I see that this use was not quite correct. Oh, that's a matter of taste. Thank you, anyway. So, dear colleagues, my review. Oh, I beg your pardon, I forgot to give the floor to Levon. Yes, Levon, please, you have the floor. Well, I want to support the colleagues, saying that the relevance of the thesis is quite high and the qualities are quite high, and green energy, that's quite a popular topic. And I would like to mention that synthetic work was quite immense, and unlike many works on organic chemistry, he really developed substances, not just carried out the tests. And that's quite a serious contribution. And I had several questions. On page 35, you mentioned that conducting a restoration reaction for nitroglycerin is complicated by heterogeneous character. So it seems to me that 4A was quite all right. Then, we know that it's rather problematic to obtain monosubstituted fullerene C60 because usually you get a mixture of radioisomers. The question is as follows. You mentioned the yields from 20 to 83%, but it's unclear. Did you calculate reacted fullerene or the one that was taken into the reaction? And second question, why using 2 moles of aziridine for 1 mole of fullerene, you get 1 isomer? That's not quite clear. And the last question was about the stability, but this question was already asked and answered. Therefore, I believe that I can say that the thesis by Artem Strelnikov on the synthesis and photophysical study of substituted porphyrin-fullerene dyads with phase 2 edge chromatophores and chromophores alignment meets the requirements of the orders of September 1st, 2016 on the procedure of granting academic degrees at St. Petersburg State University, and Mr. Strelnikov deserves the academic degree of Candidate of Sciences in Chemistry in Specialization 143 Organic Chemistry. And Articles 9 and 11 of the above-mentioned order are not violated. That's it. Thank you. Thank you, Levon Borisovich. So, Artem, you can answer. Yes, thank you very much for the review. As for the first question on the conversion of reduction reaction, the analysis of reaction compound using NMR showed high content of non-reacted nitroporphyrin. Therefore, the preparatory yield of the target product of this substrate can be higher. And as for adducts, indeed, when we conducted the reaction with lack of fullerene, the proto-reaction can give us a lot of poly connection products. And in this work, we used aziridine component, insufficient aziridine component. Therefore, the yield is calculated for it. Please take away the mask. Yes. Yes, and the excess of fullerene allows us to produce less byproducts. And as for the stability, yes, I've already answered this question. Okay, thank you. So, Professor Petrovsky, are you satisfied with the answers? Yes, I am. Okay, in my review, basic points. I fully agree with Levon Borisovich and with colleagues that that's a huge synthetic work. Even without this additional physical chemistry, Artem can get organic chemistry degree. So he's a master of organic synthesis, and that's an art. And now let me develop on the remarks. So the questions are as follows. In literature review, you give the basics of the theory of electron transfer by Marcus, and you could expand this sector and consider the expanded concept of electron transfer within the framework of Robin and Day approach. And the Robin Day approach, based on the assessment of values of energy of reorganization of electronic coupling, allows us to classify donor-acceptor systems using a charge transfer degree. This approach could be used in the thesis. Then, why do you believe that porphyrin-fullerene dyads have this construction of face to edge? Because the presence of tetrahedra pyrrole fragment can distort the axial symmetry. And then, when studying photophysical characteristics of dyads, we've seen that a fullerene component can give triplet states. Did you use electron paramagnetic resonance to confirm that? And overall, I would like to mention that this is by Artem Strelnikov meets the requirements of the order and the procedure of granting academic degrees at St. Petersburg State University, and Mr. Strelnikov deserves the academic degree of Cognitive Sciences in Chemistry, Specialization 143, Organic Chemistry, and Articles 9 and 11 of the above-mentioned order are not violated. So, Artem, please. Thank you very much for the review. I agree with the comment on literature sources. And as for the orientation of chromophores of face to edge within the framework of the work, we take average geometry, and this term just demonstrates either orthogonal location, and in this case there's no interaction of orbits, or parallel as face to face. In this case we can have an alternative. The presence of linker in these dyads excludes conformations in which distortion of from the axial symmetry would be sufficient for the interaction of orbitals of porphyrin and fullerene. Therefore, we make this conclusion about the orientation and alignment. And as for triplet state conformation, no, we did not use electronic paramagnetic resonance. Their absorption band and the lifespan that exceeds several nanoseconds, and lack of signal for porphyrin components. So this all demonstrates triplet fullerene state, and thus we decided that there are triplets here. Okay, yet another question. Do you exclude this transfer of electron without the linker directly? So maybe face-to-face would be better, edge-to-edge would be better. Well, regardless of the acceleration process, this can give us the reverse acceleration, and that's not good for photovoltaics. Okay, thank you. So, distinguished members of the board, is everyone satisfied with the answers? Are there any additional questions? None. Okay. Then, I can give the floor to those who are not the members of the board. Is anyone willing to take the floor? No one? Okay. Now, questions submitted during our broadcast on the website. Did we get any comments? No? None? Okay. Now I would like to give the floor to the thesis supervisor. Alexander, please tell us about the applicant. Well, first of all, I would like to emphasize the key role of Alexander Konyev, Associate Professor of the Department of Organic Chemistry. And talking about Artem, I'd say that this, is the topic that he started working with during the third year, and he still continues working in it. Many members of the board mentioned that that's a really harsh chemistry that's quite close to art, and I assure you that it's really the case. And indeed, that's rather serious chemistry, and Levon Borisovich knows this chemistry quite well, and he understands how much does it take to work with these polysoluble compounds. And Artem, managed to combine synthesis with mastering really remote sectors, like mastering of methods for photophysical studies. And he also demonstrated a lot of other achievements. He managed to efficiently interact with scientists from other departments, like a laser chemistry institute and the Department of Electrochemistry, high molecular compounds department, and that's also a positive characteristic for him. And the thesis that we are discussing today, I believe it characterizes him quite well, and I have no doubts about the fact that we have an established scientist here with good future, good academic future. Thank you very much. Professor, does anyone else want to say something? Maybe Alexander Konyev? Maybe you'll say a few words. Distinguished colleagues, good afternoon. I carried out the direct supervision of the experimental part of work and worked together with Artem, and I can say that indeed Artem demonstrated very good skill in this harsh chemistry, and I support Alexander Feodosevich who mentioned that, and colleagues who mentioned that. And he worked quite accurately, and he has very good skill in conducting experiments, so this all characterizes him, and he also has profound knowledge of all the physics and chemistry analysis methods. He knows them all for organic compounds. He is proficient in NMR spectroscopy, and during his stay at Tampere, he got experience in working with photochemical studies, and the results of his work, the synthetic part was conducted at our university and photophysical part was conducted in Tampere, so these results were published in the American Society Journal. And the results of this work were assessed as decent, so these results were given on the cover of the journal, and I believe that's a good demonstration of the quality of work. Therefore, I support all the colleagues who said that Artem certainly deserves the degree of Candidate of Sciences in Chemistry. Thank you. Thank you, Alexander. Distinguished colleagues, any other questions or speeches or comments? None? Okay. Then we stop taking questions. And I would like to ask everyone if there are any comments or remarks about the procedure of our session, maybe the questions regarding with the remote access. Levon, any questions? No? Dmitry, no remarks? No remarks? No comments? No comments as well? Okay, the vote then. Question to the members of the board. Dear colleagues, before the start of the vote, we can announce a break to discuss all the results without broadcast. Do we need such a break? No. Okay, no need for that. Then I'd like to mention that it's 10 minutes past 3. So the broadcast is on, and we need to check whether we all hear and see each other. Yvonne? Yes, I hear you and see you. Okay, now the final point. I raise a question on the award of the academic degree of Candidate of Sciences in Chemistry to Artem Strelnikov. And now we're going to have an open vote. And I would like to emphasize that voting for the award of the academic degree, each member of the board agrees that Article 11 of the order is not violated. So, Article 11. And this is the applicant for the academic degree is obliged to cite the author and or the source of material or individual results borrowed. Using the results obtained by the applicant personally and or in co-authorship, the applicant for the degree is obliged to note this circumstance in the thesis. Let me remind you that the decision of the Dissertation Board on conferring the academic degree is positive, provided more than 50% of the board members, but not fewer than 3 people voted in favor. That's in conformity with the provision of the order on the procedure of granting academic degrees at St. Petersburg State University. That's Appendix 2 to the order as of November 19th, 2021. So let's vote. Professor Daryan, what's your opinion? I vote for the award of the academic degree to Artem. Okay, Ivan Zorin. I also vote for the award of the academic degree to Artem Strelnikov. Okay, Andrei Mereshenko. I also vote for the award of the academic degree. Levon Borisovich. Yes, I also vote for the award of the academic degree. And I, chair of the board, also vote for the award of the academic degree to Artem Strelnikov. So out of the 5 voting members, 5 voted for the award of the academic degree, no one voted against the award of the academic degree, and no one abstained from the vote. Therefore, we award the degree of a Candidate of Sciences in Chemistry in Specialization 143, Organic Chemistry, to Artem Strelnikov. Artem, your finalizing remarks. First of all, I would like to thank the members of the board for the time that they spent on my work, and I would like to thank Professor Khlebnikov for his supervision, and I would like to thank Alexander Konyev for his effort, and I would like to thank my spouse who supported me in my preparation. Thank you. Artem, once again, we would like to congratulate you on the award of the academic degree, and I therefore announce that we close the session, and let's congratulate Artem. So, please turn off the broadcast.